This week's topic is going to be homebrew and kit building. And I think what we can start out with is talking a little bit about the actual kits or what you can do with homebrewing. And Dan's been doing this for quite a while. So, Dan, are you able to talk a little bit about kind of the things that you have done? And then maybe if we have time, we can get into some of the tools that might be good to pick up.
Yeah.
Hey, Max. Max.
Yeah. Hey, Scott.
Oh,
hey.
I don't want to interrupt at all, but if we have time, I do have a kit that I'd like to share and tell people about at the appropriate moment. So
absolutely.
Yeah.
So Scott is an avid homebrew and kit builder. So I'd love to have you share that.
I'm very slow, but making slow progress. But.
Yeah.
Well, that's true for all of us. And yeah, he's really jumped on board here. He's doing some cool stuff that is kind of up to everybody's game. So I'm really looking forward to getting Scott, to tell us what he's up to.
Yeah, that'd be awesome. Yeah. So Dan, did you want to talk a little bit about kit building? I did pull up some websites, but I'm going to stop sharing for now in case you want to show anything that.
I might wave a few pieces in front of the camera. Basically, radio kits have kind of a long history in radio, what they call home brewing, which is basically making your own equipment from scratch. Goes back to the beginning of ham radio. In fact, in the very earliest days, in the 1890s, 1900s, you couldn't even get parts. Parts weren't even made. So people were making a lot of parts on their own and assembling their own radios, from whatever they could find. So there's a very long tradition of that in amateur radio. And in fact, in the earliest days, the homemade radios were far better and far outperformed some of the very earliest commercial day. And in fact, about the only company that was making anything remotely that you might call commercial, quote unquote, was Marconi, and maybe a couple of German companies. And you've probably heard of Marconi because they made the radios for the Titanic. And but they were, unbelievably expensive, and their use was quite limited. A lot of it was designed for working on ocean liners, and massive size equipment. So amateur radio operators started building their own gear, and actually fairly early on, we're actually able to outperform some of the commercial stuff. In fact, amateurs were a primary means of communication with the Titanic when a lot of the ships were unable to reach the vessel to report what was going on and trying to rescue people. And it has just continued over time as people develop new technologies. The first tubes. And in fact, there are even amateurs at that time who were making their own tubes, which is pretty fun. Guys who had learned how to be a glass blower and put stuff in. So, I mean, we can take it to quite a level. But anyway, so that tradition exists. And, all the way up through the 1930s and all the way up into the 50s and 60s. In fact, I'm looking at a picture of a young man who may have done some kit building and home brewing in his day. Jay, I see your picture there. And I think back probably a few years ago, as I recall, you made some of your own radio gear, didn't you?
I sure did.
Yeah.
Everything. I've made receivers, transmitters.
Right.
Power supplies, and of course, all the antennas. So, that's what really excited me about ham radio was building all that cool stuff and testing it.
Yeah, exactly. And a lot of us in those days couldn't afford to do much else except build it. So you'd scrounge around. I used to go around and collect old TV sets. And Jay's nodding his head. you know, we'd go get TV sets and scrounge them for parts and unsolder things and build stuff. And as the joke is, I don't know if Jay experienced this, but I'm sure he did. The one most important thing about home brewing in those days, and I think it's still true to this day, you're not really a home brewer or kit builder until you let the magic smoke out. In other words, you do something and all of a sudden there's a big puff of smoke and something might go kind of crazy and there might be some electricity flying around. And then, you know, you're really a home brewer. As we say, you know, letting the magic smoke out. And I still continue that tradition. Not too long ago, I burned something up. Anyway, so that continued to evolve. And probably the company that really got kit building and all of that going was in the 1950s and 60s, was a company called Heathkit. And I know Jay's nodding his head. He's probably built some Heathkits. I know I did. Heathkit actually started out in the 1930s making kit airplanes. They made, you know, airplanes that you could build in your garage and fly, which people did. And then gradually, after World War II, with all the surplus equipment that was available, they started making all kinds of radio equipment, and they targeted hams in particular for building. And they were kind of the gold standard. They had these wonderful manuals, very big, very easy to follow. Many of us learned how to solder and build radios through using Heathkits. And you know, in those days, you saved quite a bit of money, you know, building something. So they were always kind of the gold standard. I built a bunch. In fact, I've got a bunch of Heathkits around here that I've kind of torn apart and rebuilt. And then this tradition has continued right up to present. There's quite a few kits. It kind of died down 70s a little bit, but then in the 1980s and 1990s, there was a big revival, particularly among high frequency radio users and QRP radio. Yeah, in fact, Max just put up a thing here by the QRP guys. And they started developing kit radios, small compact transceivers and radios that people would build. They weren't particularly complicated, but you know, you would build them. And that really kind of sparked a lot of interest in kit building. And then what we call homebrewing, which is making it from scratch, you know, which many people, I think Scott has done a lot of that on his own too. So I kind of, you know, got back into kit building in the mid 80s. And I don't know, I probably built, I don't know, I've lost count, maybe 40, 50, 60 kits. I don't know. You know, you build them and you use them and you give them away or sell them or move on, or some I still have. You know, and with the advances in technology over the years, you know, the parts and the style of building has changed. So now you can have very compact radios that are fairly still quite inexpensive, but are very high performing radios. You know, so that makes it a lot of fun. So you don't have to spend an arm and a leg to kind of get into, you know, building radios. There's not so much in the VHF world. This tends to be more in the HF world, just because, partially because the VHF equipment is a little finickier, a little harder to build. The tolerances are a little tighter. So, you know, that's, you know, and then this has continued to this day. And there's quite a few companies that are doing kits. Elecraft, which is one I'm particular favorite of, has also kind of pioneered a lot of kit building in the 1980s and 1990s. In fact, kind of the gold standard for kit building is a radio that they came out with in 1990, 98, I think, or 99. And they still make this kit and still produce it today. And it's a wonderful radio. I built mine not long after they put it on the market. It's called the Elecraft K2 transceiver. And the K2 name comes because the guys were very much into outdoor and climbing and all kinds of activities. So K2 was one of the, Himalayan mountains. Yeah, here's some pictures of the K2. And I still have mine. I still use it. Wonderful radio. It's a little behind technologically now. It's 20 plus years old, but it's not something you would want to build for your first kit, believe me. But
how long did it take you to build?
I think I took about 6 weeks, just kind of doing an hour or two a day. But the instructions were superb. And, what was nice is also, and a lot of companies are doing this now, but Elecraft pioneered this. You would build a section of the radio, and then they had, as part of that build, you could test the functionality of that section before you went on to the next one. So in other words, you wouldn't spend all this time building a kit and then, hope that the first time you turned it on that it worked. You would test it as you go. For instance, they had, a small frequency counter built in, so you could test the sections, as you started to build it. And it's still a great radio to this day, and I use it quite a bit.
I had always thought about, getting a K2 and building it. I have not done that. I understand that they're still for sale and you can still build them.
Yes.
But because it is not necessarily a modern transceiver. The K3 or the KX3, which is sort of like the more modern replacement for the K2, is sort of a kit in the sense that you can either order it as a kit where you're not really doing any soldering. It's more of just like following directions and putting the parts together. It took me, I think, about 5 hours just going very slowly. But you could easily finish it in a day or a weekend if you were going really slow. So it's still sort of a kit, but you can actually buy them fully built out.
Right. The big difference, and if you get into kit building, you will hear this phrase quite a bit. The big difference now is like the technology for the KX3 and the newer radios, and probably some of what Scott is doing, is using what they call surface mount technology, where you have very, very small parts that are soldered using some pretty sophisticated techniques. And it's a little trickier to do. In fact, I have tackled some of it, but frankly, it's a little hard for me because the parts are so small and so hard to deal with. I prefer the kits and what they're called through the hole components, which is what the K2 is. In other words, you have larger components and you're soldering, transistors, you're soldering a little bit larger gear into the radio, and it's a little easier to do as opposed to the surface mount. So, if you're tackling a first-time kit, they're right up there through the hole. Perfect example. You have a little larger resistors. You can see things, you can get to them, you can solder them, and inevitably you'll make a mistake and you have to desolder it, because I've had to do that plenty of times. With the through hole components, you can actually take stuff apart and redo it, So the K2 is basically what you would call a through the hole component radio. But it's very close in performance to some of the new ones, even though it's still a little bit older. And it would continually support it and upgrade it, over time.
And the nice thing about kits is that there's a lot of smaller companies that still put fairly simple to fairly complex kits together. And if you were just starting out with kit building, you probably want to start with something fairly simple. And so my recommendation, and I'm anybody else that's done kit building, please feel free to chime in. But if you do, if you go to like qrpguys.com, you'll see that some of the kits that they have, and I'll give you an example. This is a fun little Morse code keyer. Not that one, the first one. They have a couple of different kinds. And it just comes on a little printed circuit board. And here's what it looks like before you put all the parts on. And you're putting on all through-hole components and just soldering them on. It took me about 45 minutes to put all this together. So it's a very easy kit. And they even actually tell you kind of the difficulty scale on a scale of 1 to 5, 5 being the most difficult. This is rated at a 2. So it's kind of like a first time kit thing. And even just the real simple stuff, like I went to eBay and just typed in soldering practice. There are some that are for SMD or SMT, surface mount technology, that you probably don't want to start out with. But there are some, like here's an emotional heart soldering kit for beginners. It's $14 with free shipping. And it's actually a cool little product. It's all through hole. And it's pretty easy to solder up, probably in 20 to 30 minutes, depending on how good you are at soldering.
Yeah, I was just going to show this other kit that Marino, who's on here, dropped off to me a while back, and he said, hey, build it. I keep wanting, I'm going to make him build some of these someday. This one, I think, took about an hour. If we can hold this up there, this is also a keyer for those, just engaging newly in Morse code. A keyer is the device that allows you to send the Morse code symbols directly, by attaching, a Morse code key. In this case, you can even do it with your fingers, attaching directly, or without a Morse code key. So you can see it's pretty simple, pretty basic. There's, I don't know, maybe about a dozen parts, and pretty good. And you actually get a very useful item, In fact, I'll see if we'll fire this up here. If it'll, come on now. My battery's dead.
So I put this up on the screen for the people that if they want to see it. So this is $29, and shipping is $5. But it actually is a pretty cool little product.
Yeah, here's right there. I'm just using my fingers, right, to generate. Whoop, almost. And there's my call sign. So, fun kits.
Well, that's awesome. And Scott, did you have something that you want to show us?
Let me unmute. So so I've been working on it's not really a kit. It's more of a DIY. Although I can't. Yeah, they do make a kit for this. You can buy kits for it, but mine is not a kit. Mine is I basically took the schematics, made a few changes to it, and made my own boards. So let me show you that. It's called the UCX is the name of the project. And so I made a 2-board radio. So this basically the digital section of it. It basically contains a small Atmel microcontroller. So this is Arduino compatible. So the software is Arduino, which helps a lot because it's an open source software, so you can take it and modify it and so forth. So that's the sort of the digital section, and also the demodulators on this board. It's a very simple demodulator. I'll show you schematics in a second. And then this is my, whoops, upside down. This is my filter board. So this is a 2-band filter board. I'm going to set it up for 20 meters and 40 meters. And it has 2 relays on there, so it automatically switches bands through the software when you switch bands in the software. So let me see. And I built 2 sets of boards. That's one set. The other is actually running here, at least partly running. It's a little bright, I guess. I don't know how to get that to come into focus. Can't see, oh, hang on, let me see if I can, there we go. So so there it is running. It's running the USDX firmware, and I haven't attached the filter board to this one, so I've just been sort of playing around with the firmware, making changes to the firmware and so forth, because I did make changes to the schematic, so that means I needed to make corresponding changes to the firmware. So that's been fun. Let's see. So yeah, I don't know. Go back looking at this. The smallest part on here is this guy right here, which is that's the SI 5351 frequency clock generator, and that's in I think it's a 0.5 millimeter pitch, which is pretty difficult to solder. I actually did not do that one myself. I have a friend who's a lot better at this. My eyesight is not good enough to do this. But you know, with the right equipment, you can, you know, anyway. So this is probably not a project for a beginner. That's the most difficult one on here. All the rest of the stuff you can pretty much do with a regular soldering iron, and just use the you know, pretend the pads, put the chip on it, and then hit each of the pads with a soldering iron, and that you can actually do that on most stuff except for the really small stuff like that one. So let me think if there's does anybody have any questions on what I've said so far, or
So one of the things that you're showing us is a printed circuit board,
yes,
or PCB, and it looks purple here. And I don't want to spend too much time on it, but it used to be that printed circuit boards were something that you wouldn't do necessarily as a hobbyist, or if you were to do them, you'd have to make them at home with your own toxic materials at your house. But now you can send them out. Do you want to tell us a little bit about that?
Yeah, sure. There's a great company, actually, I believe they're in Tigard, called Oshpark. So, and they will make circuit boards, you know, at this complexity, at this is like, my circuit boards are like 8 mil pitch on the wiring, which is, well, except for that one little part. Anyway, they had no problem making this part, and it's relatively cheap. I think I paid, well, I think it was like $50, but that was for three board sets. So anyway, so like $15 a board. So not super cheap, but that's for a 4-layer board. If you do 2-layer, it's quite a bit cheaper. And their turnaround is on the order of 2 weeks. So from the time that you place an order until you get the boards back is about 2 weeks, and that includes shipping, because you know, they're just in Tigard, so shipping was only a day, I think. Anyway, yeah. So that's and there are free software packages for doing circuit board layouts, so that's not an expense either. So there's one I think most people are using these days, is called KiCad, KiCad, or Eagle is another one, but I think most people are actually using KiCad now, because KiCad is completely free. Like Eagle offers sort of like a free hobbyist version, but KiCad is completely free. All features, nothing is left out. But to be honest, probably the free version of Eagle probably works just fine.
Hey, Scott, I just had a question for kind of backing up a little bit for those who may not be familiar. Now, you came up with some of these circuits yourself, right? And then you put them into this program. Did you sketch them out by hand?
No. So like I said, I did not use KiCad, but KiCad would be used for that. I have another program. If you want to let me share my screen, I can show you that. Well, actually, I could just point my camera at it too, if you want.
Okay. Yeah, anyway, just kind of, starting from ground zero,
So here's the schematic of the digital section. This is the AT Megapar. I don't know if you can see where I'm pointing here, but that's the microcontroller. This is a Talo mixer. It's the Dan Talo. It's from Dan Talo came up with this. I don't know, 20 years ago or so. So he uses the Talo mixer. Here's the frequency synthesis chip, the SI5351. And this is all sort of just, user interface, audio amplifier, the mic jack, Morse code paddle, user interface switches, rotary encoder for the frequency tuning. So really, most of the radio is right here on this first page. If you don't count connectors and other sort of, power supplies. This is a 3.5 volt supply, and I actually put a switching power supply on here as well, which is so easy these days. That's a switching power supply that can take. I forgot the specs, but it can probably go up to. You can have like 20 or 30 volts DC in, and it'll generate the 5 volts out. Fairly efficiently. And that works fine. No, and I'm not noticing, it's pretty clean. So anyway, that's the schematic of that one. And then the, I can actually have the schematic for this is the filter board. And basically this is a relay control chip right here. It's basically it's an I2C port expander. And that basically just controls a bunch of relays. And each of the relays switches in a bandpass filter for each of the bands. So this, I actually drew up schematics for a 9-band version. My first version that I actually had boards made for is just a 2-band, just to test it out and make sure it's working. But eventually, I don't know if I'll do it or not, but it's possible that I could build a 9-band version of this radio. Anyway, so.
Yep. No, I was just going to ask, where did you know to go get these circuits and incorporate them? In other words, we're just kind of stepping it back because some folks, this may be totally new to them and they go, where would I ever find this? Because you're kind of using building blocks, if I understand.
Yeah, I didn't start from scratch. I started from an open source project called USDX. And I think I just came across that just by, how you do, just browsing things on the internet and looking for projects. And the USDX actually started out as the QRP Labs kit. Somebody took a QRP Labs kit and hacked on it and basically moved a lot of the functionality from hardware to software to simplify the radio. And then once that was working, people started making dedicated versions of the circuit boards like I did, which basically just is the original QRP Labs kit with all the stuff removed that you don't need. And just so to be clear, they were communicating with I forgot his name, but Hans Summers. Hans Summers, I guess, is the original of the original UCX design, and they got it cleared that through him that it was okay to do a non-commercial based kit based on some of his ideas. So there wasn't any, and basically Hans actually stole some of his ideas from Dan Talo, for example. So, I mean, he used the Talo. I mean, nothing's original, really. Well, there are some original things, but a lot of stuff is borrowed, and this kit is no exception. There are parts that are borrowed from other places and put together, and yeah, so it's an open source project. If you go to, I don't know, if you just go online and search for USDX, you'll find all the info about it.
Well, thank you very much, Scott. I really appreciate you showing. And for those of you who are wondering, like, if this is what kit building looks like, yes. However, Scott is on a scale of 1 to 10 is much, much closer to 10 than anybody else, here. So being able to design your own circuit board and actually modify your circuits. So that's kind of where, if you're really good at kit building and you want to get there, the tools and everything are definitely out there for you to basically become your own mini production house if you wanted to.
Yeah. Well, I'll just add that it's you do this for fun. You don't do it to save money, because I'm probably going to spend I'll spend probably at least $200 on parts and so forth to build a couple of radios. So which for the functionality that's there, you could probably find something equivalent, or anyway, it's not to save money, it's to have fun. So I'll just put that out there.
Thank you very much. And I was going to turn it over to Etienne now, because he has a couple of kits that he built that are very much ham radio related and pretty cool.
Yeah, if my screen keeps showing up, then this will work well. I'm going to show 3 kits that are all for HF radios. Really, 2 of them Morse code only, and they're full kits where all the parts are provided, although certainly in each case there's some modifications. The first one, and an easy kit to build, is a antenna tuner. This is the Soto tuner by used to be called Hendrix, and now it's QRP Kits, I believe. I did modify it because I didn't like the exposed terminals, and indeed NFED tuners can give you quite a bit of voltage on that red one. And it has a built-in standing wave ratio bridge. It's got a light and where's the switch? And a switch so you can operate or tune. An easy kit, again, a few hours, really simple. And it allows you to use an NFED half-wave antenna, which is great for portable operation. Next up, I told my partner, K7IMA, that real hams build their own stuff. And I encouraged her to consider, thanks, Max, for putting that up, to consider building a radio. I said, this is only $50. It's a QCX from Hans Summer that was talked about earlier. I got a dog here that wants to get at her toy. And I need to get the toy back out so that she can move along the path. Yeah, she's moved along the path. Thanks for that distraction. So yeah, it's Kim's first soldering project was this radio. The enclosure, I have to say, is a sandwich box that I put together. But this radio works. She's made contacts with it. And it's CW only, a single band, and beautiful design work. And it's all through-hole components. You can probably see here the through-hole density is pretty tight, but I only had to fix 2 things when she put a in the hole. And the last thing I'd like to show is something that I built a few years ago. Yeah, the newer versions, the QCX Mini might not be the best one for a first-time kit builder, is what I've read. They make a QCX Plus, which has a much bigger printed circuit board, much easier to build, comes with an enclosure. You don't have to use a sandwich. A number of years ago, Steve Weber Designs, yeah, QCXP for Plus. Steve Weber offered his MTR series. This is one of the original kits, a 2-band QCX. I took a year to get up the nerve to build this. As Scott was mentioning, surface mount parts. This is also in a container. You can see the parts are terribly small. This printed circuit board will fit in an Altoids container. And Essentially, I built this using a solder paste where you put a little dab with a hypodermic needle, paste on connection, stick down the part, completely fill up one side of the printed circuit board. Remember, it has ports on both sides. Put it on a hot plate and use a hair dryer, well, fancy hair dryer, to melt the solder. And it actually worked. I was in shock. So did Kim's QCX20. It worked when she first turned it on. So those are kits where everything essentially is provided for you. No design is required. And I would say that the instructions that QCX puts together, I'm going to post that, Max, are the best instructions I've ever seen. I haven't seen instructions like that since Heathkit. They are brilliantly, beautifully written instructions. It's almost impossible to go wrong following it. It's quite a reward to be able to do that and have anybody be able to put one of these together.
So Etienne, would you, for somebody that kind of has already put their, dip their toes into soldering, they know a little bit about it, would the QCX Plus be a good kind of next kit for them?
Yes. Again, handsome, beautiful instructions. It's very cost-effective radio. It is CW or Morse code only, but it's a beautiful piece of work with built-in test equipment. It works really well. A great little radio.
And I really like the cost too. For somebody that wants to get into something like this, but not spend hundreds of dollars on a kit, $55. I don't think that includes shipping, but shipping is not very much.
And it may not include the enclosure either, which is a pretty good deal. Enclosures are actually the hard part to come up with usually. So it's nice to have one that looks nice and all fits together, fits your radio well.
That's awesome. Thank you very much for sharing those, Etienne.
Sure.
So I have something to add about enclosures.
Yeah.
And I guess, it's 3D printing, which is, I can show you this. This is an enclosure that I put together for the radio that I'm working on. Basically, it's it's just 3D printed. And that's probably a whole nother subject, but I mean, it is possible to, a lot of these kits do have, if you go on a place like, it's called Thingiverse. So if you go onto Thingiverse, you can find some enclosures for some of these kits. And if you don't find it, contact me and I can design one for you.
That's awesome. Thank you very much. And finally, Chris, I apologize. Yeah, we did talk a little bit about SMD, but did you want to talk a little bit about your experience with Surface Mount?
Just actually, Etienne stole my thunder a little bit. That using the hot plate to do surface mount soldering that got me through a lot. Using a syringe to put solder paste on the circuit board and then tweezers to move all of the parts over, and then just setting it on here and keeping an eye on it. I found that my other passion is modular synthesizers, and some of them have more complicated circuit boards that aren't so tolerant of heat. And what I ended up finding was on eBay, these T962 ovens that are basically infrared solder ovens that you can put a board in, and they have a feedback circuit that monitors the temperature, and when you're soldering circuit boards, there's generally a curve that you want to follow about how fast you heat up and how fast you cool down and how hot you get. And so this has several of those temperature curves plugged into it. So basically you go through that process of putting all the solder on the board, putting all those little tiny pieces on the board, you stick them in here and push a button, and about 20 minutes later, you get a nicely soldered board. Unfortunately, what I've discovered is that the prices on a lot of this stuff has skyrocketed with I think COVID, that is driving people to really get into home hobby stuff. And so I think I paid $150 for it a couple of years ago, and now they're like $300. I'm hoping, of all the things that you would expect to go up in price. Imported electronics is not one of them. So
yeah.
And then as far as squirting the solder, the other thing that I have found is, again, a boatload of these. And in the case of both of these, there's any number of manufacturer names that they're sold under. I'm guessing they come off of 2 factory lines, and whoever wants to put their name on it bids. This is a pneumatic solder squirter. It's basically, it's a syringe. There's a little button there, and this is an air tube that runs down to this guy. And at the other end of this is a cheap air compressor I got off of Amazon for airbrush. And so you push this, and the syringe, and there's actually a little bit of solder paste in there now. It squirts out just a tiny amount of solder paste. And if you're doing a board that has a whole bunch of solder points, it's really handy to just be able to go click, 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 click.
All right, Chris. Now, why would somebody, if through hole is a lot easier than surface mount, because surface mount generally are very, very tiny, why would anybody want to do surface mount?
So I actually would kind of disagree with it. Having done a lot of both, I like surface mount a lot more now. I mean, it's tiny and my eyes are crappy, but tweezers and I have magnifying glass headset. It's far easier for me to go through and plop down all of the solder bits and put the components on than it is for me to do through hole, where I've got to bend leads, I've got to get stuff in the hole, solder it, flip it over, clip the leads. Maybe I'll do 6 or 7 components at once. Then I've got to flip it, solder it and make sure that I'm not interfering with other leads while I'm trying to get the soldering iron in at an angle to do the soldering. It is a little less complicated, which sounds funny because it's all this really tiny stuff, but yeah, it is just a little bit easier than dealing with all of the leads and whatnot that you have to with the through hole thing.
Yeah, it sounds a lot faster, I guess, if you're doing like 10, 50, 100 components. And then also the price, right? Like I know that resistors, transistors, they're pretty cheap, but surface mount can be even cheaper than that.
Yes, for sure. The surface mount stuff, if you're willing to buy in bulk, you get huge deals on stuff. And one of the things that I found that I kind of enjoy is that I got lots of stuff here. You can buy these sample books that basically are a whole series of resistors. I don't know if you can make these out. Yeah. So these are all 805 resistors of various values, and you get a book of 500 or 1,000 of these for like $30. And that's, yeah, that is, you're not going to find through hole resistors that count and that variety for that cheap, unfortunately, unless you've got a good connection at a vendor or something like that.
Yeah. And have you found that sometimes it's easier to find surface mount components versus like through hole if they're being discontinued?
So with integrated circuits, that's the big thing, especially coming in the audio world. A lot of the older audio circuits or audio components aren't being made anymore. The particular echo chips or processing chips are not made anymore, or they're cheap knockoffs, things like that. I think the surface mount's going to get there. I mean, it's just because stuff gets old, technology gets old, and things move on. And I've run into it a couple of times where I can't find something that somebody has specified. It's almost always an integrated circuit, though. Resistors, capacitors, things like that. They never go out of style.
Yeah. Well, thank you very much. I really appreciate that. And somebody in the chat is asking if you have a link for the solder pump that you showed us.
Ooh, I sure don't. And it might have been sold as a glue pump. I don't know. Let me dig around and I'll throw it. I got it on either eBay or Banggood, one of those two. And then the air compressor is an Elite 125. Oops. There we go. Elite 125X. Pretty sure I got that off of Amazon.
Nice.
And then I think I needed to buy a couple of fittings. And there's, in the case of both of these, there's an active bunch of modders out there that are trying to improve them. There's people that have figured out the shortcomings of the super duper cheap oven, and they're like, oh, if you move this around here and reprogram the firmware, you get a much more consistent cook out of it, and all sorts of hacks and stuff. I will see if I can find a link for the solder pump.
All right. Thank you very much, Chris. I really appreciate that. So at this point, I kind of want to just open it up to questions. Does anybody have any questions on kit building, homebrewing?
Hey, Max, before I was going to share this kind of funny story.
Yeah.
Then maybe we can talk a little bit about tools. One of the things that I've done over the years when I would see a kit that I liked, I would go, oh yeah, I'm going to buy that and build it. And, and I would do that and I'd toss it in a drawer. And you know how things are, you toss it in a drawer and life goes on, and you kind of forget about it. Well, this last year during, when we were all kind of stuck at home, I thought, well, gee, time to clean up and kind of go through some things. So I'm rummaging through and I find a bunch of old kits. And I found this one from 2002. Okay. And I was trying to figure out what the heck is this kit? And I'll explain here. It's kind of jury rigged and attached to a radio. And it was a digital frequency counter. Now, being 20 plus years ago, when the technology wasn't quite there, it was a single digit frequency counter. It would show one digit at a time. And I finally dug around and tried to remember, and I had bought it to use with this particular radio. This radio is somewhat interesting. It's what's called a Norcal 40, which is kind of a classic kit radio in itself that was made by the Norcal QRP Club back in the late 80s or, 1990, 91. And it was like one of the first really useful QRP kits, and very compact. Didn't have a lot of features. And in fact, the guys who designed this kit and a bunch of the other kits that the Norcal QRP Club used happened to be two guys named Wayne Burdick and Eric, I forget his last name, who went on to start Elecraft. So this was kind of their prototyping for Elecraft radios. And this still is a wonderful little radio, and I've taken it out and used it today. It's a very nice little compact 40-meter radio. Anyway, so I bought this frequency counter, almost 20 years ago to use with this radio. So I thought, all right, let's build it. So I dug around, got the instructions, built it, and I had a few problems with it. I couldn't quite get things to work. I thought, well, that's it, because who knows, the guy who he made maybe a couple hundred kits and disappeared. I searched around on QRZ.com for his call sign, found his call sign, emailed him. He emailed me back in about a half an hour and he says, oh my God, he says, I didn't know anybody still had one. And he said, yeah, that's great. He says, we'll get it working. So he gave me some ideas for troubleshooting and we got it working and attached to the radio. So, I just kind of Velcroed it on here. It's like this little frequency counter. Yeah, it's kind of kludgy and kind of ugly, but, it was such a fun little thing to dig it out after 20 years and get it working. And it all worked. And because prior to this, if you notice on this radio, there was no dial or no frequency readout. It was strictly analog in the sense that when you built the radio, you tried to figure out where it started on the one end of the dial and where it ended. I marked it on there, and, with like a grease pencil, I think, or something, or a little decals. And I would try to go through and kind of figure out, well, I think that's approximately the frequency. Well, that was about the state of technology in the 1980s. So this frequency counter was an upgrade, but it was just fun to be able to find, you know, that I did it. I've still got a few more legacy kits. In fact, I think Max may have a few too that he's still looking for.
Yep. Yeah, I think we just got one in the mail too.
Yeah.
Cool. Anybody with questions on kit building or any ham radio related questions?
Okay, if there's no questions, I'll try not to. But
yeah.
Let's go to the other end of the spectrum. This is a tube unit that I built about 2 years ago. There are still people building equipment with tubes, and this is a power supply designed to run a VFO, variable frequency oscillator, which is almost now incorporated into modern radios, but with the old radios, they weren't. So I built this supply using an actual tube and a transformer. So it's like old school technology. And I sure had a lot of fun building it. I kind of robbed a design from a magazine called Electric Radio, which is kind of a haven. This magazine is full of guys who are building tube equipment, you know, from scratch. You know, I didn't do this, but they'll bend the aluminum, they'll get the tubes, they'll get the sockets, they'll wire it up and make all kinds of interesting radios. So this home brewing and kit building kind of spans the whole spectrum from, you know, tube technology, you know, all the way to surface mount. So, and the cool thing about this is, of course, the components are really big and really easy to work on, you know, if you have bad eyesight. There's plenty of room and the wires are very easy to go. So just kind of the other end of the spectrum.
That's awesome. And you know, that reminds me that the QST magazine, which is the official publication of the ARRL. So one advantage of subscribing to or joining the ARRL is you get that magazine plus a couple others where they have kits that you can put together. And oftentimes you can have a place to order the board from if you didn't want to make it yourself. Oftentimes they'll include the schematic if you want, but it's actually, you know, a lot of them are like medium to advanced, but there are every once in a while, especially with the new Arduino stuff, there's some pretty basic kits that you can put together that are pretty cool in that magazine. Does this inspire anybody to either finish a kit that they've started or to start kit building? Yep. Looks like you have a lot of projects.
Should we take a second and talk about basic equipment for kit building?
Sure.
I don't know. You know, I was just tossing it out there. You know, one of the among the basic things, I think I emailed you or texted you a list today. You know, obviously we talk about soldering irons. There's been a lot of fairly new technology in soldering irons. This is one that I happen to use. Works out quite well. You know, and then your basic hand tools, you know, like needle nose pliers, what's called a flush cutter, which is like a wire cutter that will cut, you know, the wires flush with the circuit board. This one I happen to find I really like is a circuit board holder that I use that allows you to clamp a circuit board in there and spin it around, you know, so you can flip it easily, you know, front to back, you know, while you install the parts, and you can flip it over and do that. So this one I think was pretty inexpensive, you know, about $15, and it works quite well.
That, you know, that's just one of the things about kit building when you're doing circuit boards, or even if you're just splicing wires together. Humans weren't built to build kits. It's almost like you really do need 3 to 4 hands. And so anything that you can get to help you kind of either hold this circuit board or hold a wire or hold a component And one of the things that you can do is have something that holds the circuit board. Tape also works pretty well if you're going to hold components. And then anything that is like a third hand, usually is what they call it. And I'm not remembering the name of the third hand device. Here it is. So something like this, where you have these different arms that have alligator clips on the end. And they can either hold components, they can hold wires, or they can hold circuit boards. Really helps a lot.
Yeah, like this one, you know, I've clamped a circuit board in here, and you can see I can just spin it around and, you know, access the top and the bottom much easier than trying to drag it around.
Yeah.
Yeah.
Yeah, thanks, Jim.
Sure. And you'll find it's very easy to spend a lot of money on tools and justify it, as we all know. You know, a digital voltmeter, you know, one thing leads to another, all the various hand tools. Oh, the other trick, if you have a good relationship with your dentist or your dental hygienist, next time you go, you can ask them if they have used dental equipment. And I use the little, you know, picks and scrapers. I find those incredibly useful, you know, for doing various little things, because sometimes they'll toss them out rather than, you know, and they're still perfectly good for our use, but they may not be good for medical use. And I've collected quite a few, you know, over the years, and they're really helpful.
When you're building, are you building on ESD protected or grounded workstations?
Oh, I try to. Half the time I forget. And the one nice thing about the solder through the hole components and the tube stuff, they're very much more forgiving than a lot of the surface mount. If you're doing the surface mount and some of the integrated circuits, I think you got to be pretty careful about making sure you have static, you know, electrostatic discharge is what they call the ESD, which can fry a component. Basically, what you're trying to do is ground yourself so that you don't get a big static tap on a component, which can kill it. I don't know, maybe Scott or Chris, the other fellow, had more experience on that. I don't know what you guys do.
I have never blown anything out personally through static electricity unintentionally.
Right.
Intentionally, I know that you can do that.
Yeah, like I said, you got to let the smoke out.
Yeah.
So I have another general comment about kit building.
Yeah.
And that is, if you're interested, Arduino is kind of a very handy thing for building kit type things. I mean, there are some radios that are built around Arduino. I mean, this kit that I'm working on here uses Arduino software. It doesn't use Arduino hardware in the sense of pre-built Arduino boards, but I have another project here, which is I built a little Morse keyer, and it is basically just a I don't know if you can see that. It is just an Arduino board. I put it in a little case, but that's all it is. It's just an Arduino board. There was no soldering other than soldering wires to the Arduino board to the connectors. It's basically just an Arduino board that can be programmed to be a keyer. And you can buy Arduino boards very, very cheaply these days. Well, I mean, like on eBay, you can find them like $5 with shipping, which is kind of incredible. So that's just a handy thing for some projects, is to basically, you know, almost a shortcut is basically using pre-built Arduino components for doing some kits.
Yeah, thank you very much. That's a great comment. I can display kind of some of the Arduino boards for those of you who don't know. They are microcontrollers, so they're sort of like computers, but they do a lot of just basic input, output, and instruction a lot better. They are extremely reliable and extremely cheap, like Scott mentioned. And as far as kit building goes, they're wonderful. because they can take a very complicated project that would normally be very complicated and make it so simple that it's almost laughable. One of the projects that I would like to put together in the next week, and I'm kind of sad to say that I've been meaning to do this for a couple of weeks. It would probably literally take me 20 minutes to build this kit, and I just haven't done it yet, but I wanted to pull it up for you. And Instructables is a place that I get a lot of kit ideas from, or project ideas. And this particular one is a Zoom button box. So when you're on Zoom and you want to, for example, mute yourself or mute everybody, or switch speaker to gallery view, this is like a programmable keyboard or a button box that breaks out some of these functions. And it literally is an Arduino that you solder buttons to. That's it. Then you just plug in the cord. You have to flash program the Arduino, but this isn't really much of a complicated or complex kit to build, but it's actually really useful. This Arduino costs about $3, maybe with 50 cents or dollar shipping, and then the buttons are probably an extra couple dollars, and then you can just find any old enclosure to put it in. So I thought I'd share that with you guys. Cool. Any other questions from anybody or comments?
This is Teresa from Half Moon Bay, California. I just want to thank you all. I'm just learning everything. And when I got on this line, I thought, oh my gosh, they're going to talk about beer. I felt so stupid. And then I was laughing to myself because I thought homebrew was it. I really enjoyed that. Even though I don't plan on building my own, it's nice to know from scratch how the radios are kind of put together. So thank you so much. I really
absolutely.
It. Thank you.
Yeah, no beer. Although that beer normally goes along with kit building very well.
Thank you.
Yeah.
Thank you.
Yeah, I think a lot of us have tried to make some IPAs. I know I have. This is a little less stinky.
I think one of the biggest advances in kit building really has been a couple things. Number one is people can now use surface mount components. These were things that 15, 20 years ago were just getting started, and the home hobbyist was, I think there was a lot of worry that these very tiny resistors and IC chips would take away from the hobbyist, right? Because it was so complex for the hobbyist to actually do these. They're made for machines. They're made for automated machines to pick and place, and then ovens that, that they send them automatically through. And so they're made for companies that make computers and other pieces of equipment 100, 200 an hour. But in reality, what ended up happening, and this is kind of my observation, is that the home hobbyist has found a way kind of around that very inexpensively to use either, like Chris showed us, a hot plate or a reflow oven that's not too expensive, to actually still be up to date with all the electronics that we use, but yet there's a lot of advantages, as it turned out, with the cost of each piece being a lot less, the effort being a lot less. So I'm just starting myself into surface mount technology, transitioning over from through hole, but it's actually pretty exciting.
So I have an offer for anybody who's interested. So when you buy boards from Oshpark, you have to buy a set of 3 just because of their manufacturing process. How they cut their costs is basically they build 3 at a time. So I have 3 sets of my radio. I've built up 1 set. I've half built the second, and the third is not built at all. You might want to wait until I actually get it working, but anybody who's interested in either the half-built second set or the completely unbuilt third set, those boards will probably be available. But you might want to wait a little bit until I actually get it on the air. But hopefully it'll work, and Yeah. So
that's awesome.
And you can find me on QRPDX. You can find me there, or my email is my name, scott.l.baker@gmail. You can contact me that way either way. So.
Yeah, thank you very much. I put your email in the chat.
Okay.
And yeah, so Scott, it sounds like once you do get it working, would you be open to kind of making either the boards available to people to print themselves, or?
Yeah, I mean, so yeah, there's a couple of ways to do that. I mean, I could basically put I have no interest in commercial interest in this at all. So I'm perfectly willing to put it up on, there's a place called GitHub, which is, I can put the Gerber files up there. So anybody who wants to download the Gerber files and order their own boards or whatever. I don't know what's going to happen, but I have no proprietary ownership of this stuff. I'm willing to give it away. So yeah, that's available. And yeah, so you could either do that and order boards from Oshpark, or some of the other kit builders have actually ordered, here's an idea. You can actually order boards from a place in China, and you can actually have them do the service mount as well. So that's an option too. There are some services in China that will, if you send them Gerbers and a parts list, they'll build you a complete board and send it back. So I don't know, there's lots of options out there, but yes, I'm certainly willing to, if it works, to make it available to anybody who else wants to build one. Or if you're interested in building one, there's actually already kits out there. If you search a couple of the links that I sent out, you can, or just search on USDX, there are places you can actually buy a USDX kit that's, similar to mine, but not, same sort of functionality. So anyway.
Yeah, that's awesome. Thank you very much, Scott. One website I kind of wanted to show everybody that, and this is just a place that I have fun like looking through to find out what other people are building, is Tindie.com, TINDIE.com. And a lot of this is our home hobbyists that they build a project, but like Scott was saying, sometimes you wind up with extra boards, extra parts. And so what they do is they will actually post things here that they either sell as something that's already built, or more likely than not, it's a kit. So just as an example here, for $15 is a memory game, kind of like a Simon Says game. And it looks like it's all through hole, comes with a PCB board, holders for the batteries, and then the chips and the LEDs. So that's a good practice board. There are a lot more complicated things on here. Scroll past some of the specialty devices. Some of these I don't recognize, but here's a badge kit. And a lot of these are pretty simple. Some are more complicated, but this is just a fun site to kind of to browse and see what's out there.